Good afternoon, sir.
Hey, afternoon, Mario. What's up? You good?
Yeah, I'm good.
Good vibes. Just give me like 1 minute to
All
come,
right,
yeah?
sir. All right.
Right, so Mario, how your prep going? You feel like you ready? I'm not so ready. Hey, Christina, what's up? Good to see you. Yeah. Let's see, ready for the exam? I'm not so ready. Like, how's your preparation? How's your prep going? You're practicing? Good. If you feel like you're ready, that good. That's a good sign. All you do is just make sure so you keep getting ready, keep practicing, keep looking at some papers and stuff, and you'll be good. Uh, shoot. Uh, hmm. Put this right here. Oh. All right, so let's get started, guys. Let us get started. Let's see what we can do today. So today we're going to be focusing on some trigonometry. And oh, you say you're getting nervous because we have 2 weeks leave. Yeah, I think it's like 2 or 3 weeks. You can imagine that? Time is flying so fast. I can't believe. Like by the time you turn around and look, and then they're not move. I was reading something this week about CXC. They're asking them to move back the date, but them said, not do that. So you guys, you guys on your own basically. But I think you'll do it. All you got to do, all you have to do, sorry, all you have to do is just make sure that you practice. Yeah? Each day, at least a half hour. That's what I always say. Can't go wrong with that. And that's just a half hour until the exam come. Once the exam come and gone, at least until if you want to go to college or doing something else like that, you don't have to worry about any maths. So you just practice them for now, and get yourself ready for it. And hello to everybody on YouTube too. I hope everybody is good. Hope everybody is ready to do some math too, because I know I'm ready to do some math, I think. And we're going to see if we can focus on trigonometry. That's our plan for today. All right. So let me circle that. Yes. So we're working on trigonometry. So we're going to see what we can do in trig today, kind of like a start. And then we're going to go to, we're going to go to bearings later. So like, probably like tomorrow. Yeah, tomorrow evening, we'll do bearings. Today we focus on trig. Now, before we start, let's just kind of recap. Let's just remind ourselves of what we need to do when we're doing trigonometry. Because I know most of us are familiar with trig, but it's important for us to know when to do what. So you know in trigonometry, we have 2 sets of rules or things to do when we're dealing with right angle triangles and when we're dealing with triangles that don't have a right angle, okay? So if we're solving, anytime we meet on a trig problem, and keep this in mind, because this is kind of the pattern that we're going to be using for every problem that we're going to do now. Anytime we're dealing with a trig problem, we first have to check, are we dealing with a triangle with a right angle? So are we dealing with a right triangle, or are we dealing with a triangle that has no right angles? So is it this or is it that? No, what if we, so anytime we look at the problem, that's the first place to start. Now, what if our triangle has a right angle? Then what are some of the things that can apply? What rules apply? Let me see, let me try to jog your memory. Let me see what you know. So what rules apply in that case? You can either write it in the chat here or on YouTube. All right, so that's Christina saying trig ratios. That is definitely right. Because, so we know, say, with them be dealing, trig ratios work for right triangles. Keep that in mind. That's one of the #1 problems I see students have, is not knowing when to use what, which is why I'm doing this. So we're dealing with trig ratios, so it's like so, ka, toa. So we know that's where we're going to be going. What else? What else can we use when we're dealing with right angle triangles? All right, I see Christina saying Pythagoras theorem. Yeah. Yeah, no, that was not your spelling. It's fine, don't worry. So we know we're dealing with, when we're dealing with a right triangle, we can also use Pythagoras theorem. And do you remember what that theorem says, everybody? It says that the square of the 2 shorter sides is equal to the square of the longest side. So like if we have a right triangle like that, we have ABC, and then we have the hypotenuse, then the hypotenuse is also look so good. Then we know that we can use Pythagorean theorem. Okay? Good. Yeah, so that's something else that we can do. What if it doesn't have any right angles? Then what kind of rules what can we do? What kind of rules can we use if there are no right angles? What comes to mind? Let me see what you know. All right. Let me hear what you're thinking. A little bit with this. All right. So you are thinking sine and cosine rule. Christina. Good. Yeah. That's something that we can use. I know we're not going into bearings yet. We're just focusing on trigonometry here. So we have sine rule that we can use. Okay. So we have the sine rule. And can anybody tell me what the sine rule is? Remember that it says this the ratio of the sine and its opposite side would be equal. So A to sine A is the same thing as B to sine B. And for the third angle, it would be C to sine C. All right, good. Yeah, that's right. That's right, Z. And it's good to see you too. So that is also something that could work. Another thing that could work is the cosine rule. The cosine rule. And no, the cosine rule is, remember that it says here, I'm just going to write it. A squared is equal to B squared plus C squared minus 2BC cosine of A. Now, I don't necessarily want you to focus on remembering the exact rules. What I want you to do is to remember the relationships. That's what I want you to focus on, the things that how to link them together. You understand what I mean? I'm going to do some of that as we go along. So with that in mind, let's look at some problems. Before we start, this is what you're going to get on your exam. You're going to get your formula sheet. And that's what I said. I don't necessarily want you to remember the rules like word for word or fret if you don't remember exactly what to put where. But what I want you to do is to understand exactly how to use the rules. That's the key thing. Those are the main things that I want you. So that even if you don't remember exactly what the rule is, you know when to use it and how to use it. You know what trig rules come in like tools, like a hammer or a drill or something like that. It's important, yeah, you know, to identify a drill, but what's more important? It's important to use it. You have to know how to drill and how to use the hammer and how to do everything like that. Likewise, with the trig rules, they're just tools. The most important thing is when and how to use them. You get me? So let's see if we can use that now in some other problems. So let's start with this question. So these are some paper one questions. These are some paper one questions just to start, right? And I kind of just laid them out like this, but you know, these are some typical problems that you get there. So let's start with this one. Let's call this question one. So in the triangle PQR, in which angle QPR is 90 degrees, PR is 12 centimeters, and PQ is 5 centimeters, the length of QR in centimeters is, what do you guys think that is? Would you say A, B, C, or D? Let me hear your answers. A, B, C, or D? What are you thinking? Wait a sec. D. All right. Let's see. Let's hear what anybody else is thinking. See what you guys are thinking. All right. So somebody saying C. Let's see what's up. Let's see, all right, let's talk about it. So first, is this a right angle triangle? Yes, obviously the right angle here. So that means we're only going to use either one of the ratios or the Pythagorean theorem. But here, I want to know one of the sides, and I already have the other two sides. So because I have those two, then I can use the Pythagorean theorem. So once we have two sides and we want to find a third side, we can start thinking about that. So let's use the theorem. First, we need to find the hypotenuse. The hypotenuse is always in front of the right angle. So since our right angle is here, that means our hypotenuse is down here. So the square of the shorter sides, 5 squared and 12 squared, is going to be equal to the square of the longest side, the hypotenuse, which is QR. Okay, so I could probably write that as QR squared is equal to 5 squared plus 12 squared. And now that we know that, we just need to solve for QR. Because if QR squared is that, 5 squared is 25, 12 squared is 144, and 25 plus 144 is 169. Cool. So QR squared is going to be equal to 169. And that means QR, length of QR, is going to be equal to the square root of 169 because that's the opposite of the square. And when we do that, what's the square root of 169? It would be 13. So QR is 13 centimeters. So it would be C. C is the answer. All right. So that's how we could use the Pythagorean theorem there. All right, let's try another one. Now, the diagram below, not drawn to scale, shows the angle of depression of a point X and Z is 30 degrees. If X is 10 meters from Y, then the height YZ in meters is it A, B, C, or D? Let me hear what you have. A, B, C, or D. So the height YZ, how would you find that? Or YZ? What are you guys thinking? Let me see what you're thinking. So let me see, either in the chat on Zoom or on Facebook. What you have as your answer? All right, seeing some answers here. So let's see if we can work it out. Let's see if we can work it out together then. So, what do we know? First, again, we can see, well, the thing is, if it's usually in the diagram. So you can look out for that. It's usually in the diagram. But this is a right angle triangle. Okay. So this is a right angle triangle. It usually shows it though, so you don't worry about that. So it says X is 10 meters from Y and you want to find the height of YZ. So now let's think, what do we First, is it a right angle triangle? Yes, it is. So that means we're going to have to choose between the Pythagorean theorem and the trigonometric ratios. But we don't have enough sides to use the Pythagorean theorem. If we were to find YZ, we'd have to have that side, but we don't know it. So what we could probably do, what we would do instead is we could use the trig ratios. Okay? So now once we start talking about trig ratios, we need to think about the sides. Which one is opposite? Which one is opposite? Which one is adjacent? Which one is the hypotenuse? So let's label it first. So XZ is in front of the right angle. So we know that that's the hypotenuse. Now the problem, the angle 30 is here, and I don't see any triangles up there. But if you look at it very carefully, if I were to, let me trace it out in green. If you notice, XY and our line up here are parallel. I don't know if you guys see that. Those two are parallel because we're talking about the angle of depression, right? So here, that means since both those lengths are parallel, this angle down here, let me clear off the marker. This angle down here would also be 30 degrees. So when we realize that we have the Z there, so that angle would also be 30. And if that angle is 30, that helps us a little more because now if this is 30, then I know that over here, if I'm talking about this angle, the opposite angle, this opposite side, the side in front of it would be YZ. So that is the opposite side. And down here, XY must be the adjacent side. Everybody with me so far? We good so far? You seeing what's going on? All right, good. So in that case, since this is adjacent, this is the opposite, think about it now. We're dealing with ratios, trig ratios. I know my adjacent and I want the opposite side. What trig ratio am I going to use? What trig ratio links opposite with adjacent? Write it in the chat for me. What trig ratio links opposite with adjacent? That's right, tan. Very good. All right. Ooh, you're going to use tan. So here, that means for our angle, tan 30 is going to be equal to, because remember, so katoa tan, the tan is equal to opposite divided by adjacent. So we're going to put the opposite side, YZ, over the adjacent side, which is 10. So if tan 30 is YZ divided by 10, then I could multiply both sides by 10 to get YZ being equal to 10 tan 30. Okay? So that and that, because I know that is what's going to get rid of my 10. So therefore, that means our answer is A, 10 tan 30. Can I have a ring to it? 10 tan 30. Yeah. So A would be our answer. Anybody's not so sure about that one, or that's clear? Like you say, why it's 10 tan 30. Good. Okay. All right. All right. That's great. So those are probably some of the ideas, some of what the questions on the some of the questions on the exam probably looks like. On the paper one probably looks like. Okay. No. let us look at some paper 2 problems. Let's get into some paper 2 stuff, okay? And I don't, these questions that I have today, and I can't place what year they came from. I didn't write the year, but I know because I have them written down from a long time. So that's the thing. But they came on the CXC for sure, that I can tell you. So in this question, it says the diagram shows triangle PQR, which represents the cross section of a roof. QS is perpendicular to PSR. And using the dimensions shown in the diagram, calculate correct to 3 significant figures. 1, the length of QS. 2, the measure of RQS. And 3, the area of triangle PQR. So first, let's start with the length of QS. So let me shade it. So this is QS. To find the length of QS, let's think about it. What do we know? So I'm going to start on the left. And if you look at this triangle here, put that in yellow. If you look at this triangle, we have the side PQ and we have the angle QPS, which is 15 degrees. So I have a side and I have an angle. Since I have that, and here you see the right angle. Here's our right angle. It's a right angle triangle. What could I use? So we're dealing with a right angle triangle. I have an angle and a side. What could I use? Trig ratios or the Pythagorean theorem? Which one would you use? Let me hear what you're thinking. What would you use to figure out that unknown side? Would you use a trig ratio or would you use the Pythagorean theorem? All right. So let me see. I see Z is thinking to use trig. Simone's thinking trig 2. Great, great. Anybody else thinking anything different? Or we all agree that trig would probably be the best here? Yeah, I think we do. Yeah, because we're dealing with an angle and we want the side. So let's see how we could do that. So we need QS. So let's start thinking about the ratios now. So let's label our sides. So we know that this is the hypotenuse in front of the right angle. QS is what? QS is our opposite side because QS is opposite to the angle that we have, the 15 degrees. So since that's the case, what ratio links the hypotenuse and the opposite side? Because now what I'm saying, I want you to be thinking about it the way that we're talking about it. You're reasoning it through. What ratio links both of them? Yes, that's right. That's right. Sine. Good. So that means we're going to use sine to figure out the length of QS. So we know that sine of an angle is equal to the opposite over the hypotenuse, SOHCAHTOA, the SO in SOHCAHTOA. So our angle is 15 degrees. We want the opposite side. Well, the opposite side is QS. And our hypotenuse is 12.6 meters. All right? So since that's the case, we can do a little algebra here to get the QS by itself. Now, when I'm doing these, I kind of like to just put everything in the calculator one time. I don't like to work them out step one by one. So I'm going to multiply both sides by 12.6. And I'm going to bring up the 12.6. So when I do that, QS is equal to 12.6 times the sine 15. And I like to put it in the calculator like this so that I can get an exact answer. All right? So now let me do that. And when I do that, Probably you guys not seen my calculator. Let me get that quick. That should not be there. Let me get that quick. Where is it? I use the Desmos. I use an online calculator. Kind of much easier. All right, so you guys see my calculator now, right? Just give me a thumbs up if you see it. Okay, great. So now we can just put this straight into the calculator. 12.6 sine 15. What does that say? That says that our answer, oops, sorry, let me bring it back. Says that our answer is 3.261 something. But we only want to correct the three significant figures. So first digit 3, second 2, third 6. So we're rounding it here. So we can just say that it's 3.26. 3.26 meters. So that would be the length of QS. Right? All right. Now let's look at before we continue though. Everybody good so far? Clear? Anybody has any questions about that one? Or makes sense? Must talk to me, you know. Remember, I'm here to help you, so you let me know if it's good. If it's not good, you know, so we will look back on it. Let's say Christina. Makes sense. Good. Makes sense. Simone G, I don't know what to I don't know what to say. Oh, like GD, that's probably what you're trying to type.
Typo.
Okay, cool. Yeah. So let's go to the next part. So it says the measure of angle RQS. So let me walk with the diagram. On here. And we want the measure of RQS. And oh, I seen somebody in the chat asking, where did we get the 12.6 from? Remember, that was in the question. You see it here? 12.6. Right here, son. So that was given. That was the length of PQ. Now, what do we already know? We just figured out that QS is 3.26. Let me make that a little bigger. So that's 3.26. And now I want to find the measure of angle RQS. So angle RQS, I think I can zoom in over here. RQS, which is the angle over here. Now, put that in green. I want angle RQS. I know QR. I know this side here, and I want the angle. What would you use? Trig ratios or Pythagorean theorem? Because we know this would be a right angle triangle too. Or a right triangle. What would you use? Trig ratios or what? What are you guys thinking? Let me see in the chat. Oops, I read that wrong. Not QRS, RQS. Yeah, sorry about that, guys. It's RQS. Oops, yeah, I definitely read that wrong. So that's our angle right here. I know that we want this side 3.26. 3.26 meters. Yeah. Thanks for that. Christina. So what would we use? Trig ratios or what do you want to use? What are you thinking? Yeah, trig ratio. Yeah. Because now, let's zoom in. We want the angle and we know some sides. Let's label the sides that we know. What do we know? We know this side right here, right? And if we look at our angle, we know the right angle would be here. So this would be our hypotenuse. And we know this side over here, 3.26, which would be our what? What side is that? Is it the adjacent or the opposite? Where is that? Notice it's running along the angle. So it would be the adjacent side. Okay. So now we have the adjacent and we have the hypotenuse. What ratio links adjacent and hypotenuse? Cos. Because we know that cos theta is equal to adjacent over hypotenuse. So let's just try plugging this stuff in. So now the adjacent is 3.26. The hypotenuse is 8.4. And I want the cosine of my angle. Now, again, as I said, I kind of like to just leave them like this to get an exact value, like a dead-on value. So we know that when we want to find an angle for a cosine, then we need to think about the inverse function, okay? Because we're doing the opposite. Usually we put in an angle, get a value. Now we have the value, we want to find what angle gave us that. So let us use our inverse function. So therefore the angle, right? Angle that we're talking about, and I can put, you know the angle, well, yeah, we know the angle is going to be equal to cos inverse of 3.26 divided by 8.4, right? And you could round it out too, but you just make sure that it's to the three significant figures like they would have asked. So you have to be consistent all the way throughout. Oh, okay, sorry. All right, so let me throw that straight into the calculator. So now we're looking for cos inverse. You have to know where it is on your calculator. Cos inverse, and I'm gonna have 3.26 divided by 8.4. Right? And that is equal to 67.16 something. Remember, all our answers are supposed to be in three significant figures. So it would be 1, 2, 3. This is the third. So it would be 67.2 degrees. Right? So 67.2 degrees. So we can say, therefore, angle RQS is equal to 67.2 degrees to three significant figures. All right? Now, we did a lot. Let's see if we can move on. Let me copy this again. Got it. And now let's go down to here. We want to find the area of triangle PQR. So let me write in what we have. We know this was 3.26. And now we know the angle here is 67.2. That's what we just found. And now we want the area of triangle PQR. We want the area of triangle PQR. So the question now is, how are we going to figure that out? You know, there are different ways that we could do this one. There are a lot of different ways that we can do it. We could focus on some, focus on two, or we could just do one. I see somebody on YouTube saying half base times height. That's one way that we could do it. But then no, that means, because we weren't given, if we look back on what we were given before, we weren't given what SR is. So we'd have to find SR. And we weren't given PS either. Okay? So we're going to have to probably find PS and SR. But another way that we can do it is to use the formula for the area of a triangle half AB sine C. Anybody remembers that formula? That one could come in handy right here. I'll put it in blue. So the area is equal to half AB sine C. What does all of this mean? Well, half AB sine C, it just means that we can find the area by using two sides on the triangle and the angle between those two sides. So we can use those two to help us. So let's look at our triangle now. Zin, do we have two sides like this? Two sides that are that make a corner or that make an angle? Yeah, we do. We have PQ. Let me get a bigger thing here, so bigger thing to share it. So we have we have PQ and we have QR. But here's the problem. We only know one of the angles. We only know one. So if we can figure out the angle that should be here, then we can use that formula. But guess what? In our right angle triangle, we know two other angles. We know that this angle is 90, and we know that this one is 15. So therefore, our angle up here, angle PQS, right? The angle that we want. Angle PQS, let me put that in the whole working. So angle PQS is going to be equal to 180 minus the other angles, which is 90 and 15. We know 90 plus 15 is 105. So that means angle PQS is 75 degrees. Right? No, since we know that PQS is 75, let's put it in here. Now we know the entire angle. We know the whole angle, and then we can use our formula. Because the angle here, let me write that. So that angle, what's that angle? PQR. Angle PQR is equal to 75 plus 67.2. And 75 and 60, that's 135, 130, 75 and 65, that's 140. It's 142.2. Yeah, angle PQR is 142.2. Correct me if I'm wrong. I hope I'm not wrong. So angle PQR is 142.2. Therefore, we can find the area using those two sides and our angle at PQR. So this implies that the area of triangle PQR is going to be equal to half times, and it doesn't matter which one you call A or B. You know, this could be A, that could be B, it doesn't matter. So that's half times 12.6 times 8.4 times the angle between them, which is 142.2. So I just want you to remember, you just need the two sides and the angle between them, and you're good. So now let's put that straight in our calculator. Oops, you know, guys, I missed out something. And don't tell me, you know. Sine 142. So you understand, bud? I'm gonna go on. All right. So sine 142.2. So let's get our calculator here. Yeah, let's stay about a little bit, but that's right. 142. I'll still know what I'm saying. Watch him all right, 142. Let's stay too bad. So half times 12.6 times 8.4 times sine 142.2. And we got 32.43 something. Remember, three significant figures. So 32.44. So 32.4, because this is where we would stop. Right? So the area of PQR is 32.4. What are our units? We're dealing with meters. So that would be square meters. So 32.4 square meters is the area of PQR. All right. So that's how we would find it. Just a check. Everybody good? We following so far? What we say? Remember, if you have any problems, let me know. Now, let's jump into our last question. And that is this one, okay? So now, I wonder if you realize what's different about this one. It's a little different, right? Yeah, this one doesn't have any, well, let me leave it to you. What's different about this one? No right angle. Good. Nice, Z. So no, because it doesn't have any right angle, automatically we're starting to think about the sine rule and the cosine rule. So now we're going to be looking out for those and how we can use them as we go along. Right? So let's keep that in mind. It says on the diagram shown, RQ is 9 meters, RS is 12 meters, ST is 13 meters, QRS is 60 degrees, and SQT is 40 degrees. And all of that is put on the triangle already. So we want to calculate, correct to 1 decimal place, the length of QS. Okay? So the length QS, let me get my marker here, the length QS. So this is what we want. That look kind of shabby. Let me fix up that. Yeah, sleek. So talk to me. What can we do? You remember what we need for the sine rule and what we need for the cosine rule? When do we use them? When do we use them? Oh, let me come over here. So when do we use the cosine rule? All right, so I see Christina thinking cosine rule. Oh, you know it's the cosine rule. Why did you use that?
Because there's an angle between the two sides or something like that. I
Right.
really remember.
No, that is it. Right. Very good. So once that is one condition for cosine rule, once you have an angle between two sides and you want to find the side that's opposite to that angle. So what I usually say is like you can think about it kind of like an arrow. So once you have in your triangle, right? Once you have your angle and two of the sides between an angle, it's kind of like an arrow pointing to it. So if I wanted to find this side, then I just look, it's like you follow the arrow. I think that's an old part. I don't know if you guys know about that. But like you just look and see if you identify the arrow. So that's one condition for the cosine rule. Another condition is if you want to find an angle in a non-right angle triangle and we know the three sides. So let's say, let me put that in yellow. You know, you want to find the angle and you already know three sides. Then you can use the cosine rule as well. All right. So in this case, we have our diagram and we know we're going to use the cosine rule. So let's get to it. So again, I kind of just want you guys to focus on the rules themselves. The ideas, not necessarily the rules. So we know we just need the two sides and the angle between them. So let me call this side R because it's facing R, the angle R, opposite to R. Likewise, let's call this Q and let's call this S because it's opposite to the angle S. Then the length QS, which we could basically call R squared is going to be equal to Q squared plus S squared minus 2 QS, the two lengths that are here, times the cosine of the angle between them, the cosine of the angle at R. Right? And now we're basically just filling in our values. So R squared, we know that that is QS equals Q squared, that's 12. S squared, that's 9, minus 2 times Q, that's 12, times S, that's 9, times the cosine of the angle between them, that's 60. All right? So that would be QS squared. Now we need to use that to figure out the length of QS. So let me get my calculator again. And if you have a really good, I always tell guys, if you have a really good calculator, you literally just put in this straight in there, like you're just writing it out in there. So always, you can look for like, you know, you have some calculators I can recommend. You have the Casio with the big screen that you can use. I have my calculator here now. I don't know where it's now, but yeah, you can make sure you get a good calculator for the exam. Anyways, so it's 12 squared plus 9 squared minus 2 times 12 times 9 cosine 60. And we got QS squared is equal to 117. Right? So that's 117. What does that mean? That means QS, run out of space, it's going to be equal to the square root of 117. And what is that? Square root of 117. What is that? Oops, sorry. Square root of 117 is 10.81 something something. Remember, I said we want to calculate our answer correct to 1 decimal place. So we know say that's going to be 10.8. That's going to be QS. It's going to be 10.8. When it said not work it out as one thing, it depends. But if you, that's why I say if you calculate, if you have a good calculator, you can just throw all of it in there. So one, you have to just make sure you have a good calculator, one that you can easily write out the fractions and everything there. Because that just make it so easy. Understand? So that's one thing that you can do. So invest in a good calculator. Get a good one. I know it's kind of late, but make sure you get a good one. No, oh, you said they want to see working. They want to see working and you give them working, yes, but they can't fight you if you have this, because they know that you have some good calculators out there. But if you want to put the work in, you know, you can do that. You can put the work in. But the reason why I say put it straight through as well, sometimes when you break it up, what I've seen is you might make a little mistake here and a little mistake there that throw off everything. So that's usually my problem with students doing it one by one. So that's why I usually say, just put it in there. But you can do whatever you want. If you prefer to do it that way, you do it like that. All right, next we're finding the measure of angle QTS. QTS. So let me carry my diagram again. QTS. Oh no, I think I should leave those. Yeah, leave those. Amario, find us.
Yes, man, I'm here.
All right, good to see you. All right, let me see now. So, got my little diagram here. I want angle QTS. Let me write in what we have already. So you don't know, we just find QS, which is 10.82. Let me try to fix up this 10.8. Yeah. I now want angle QTS. So let me change it to yellow. So QTS, where is that? QTS. S. Already, Christina at it with the sine rule. Sound like that, you know, Christina. Like that. Tell me why you're thinking that. Oh, you know that.
I guess I don't really remember something them.
Remember that? All right. Let's look back on the condition. When do we use the sine rule? When do we use the sine rule? We can use the sine rule once you have a pair, once you have a known pair of angle and side. Because remember, the sine rule says the sine of 1 to 1 is going to be the sine of another to the opposite side and so on. So once, if you know one of these pairs, then you can use it to figure out something else in the other pair. Right? So once you have a known pair, that's what you focus on. You have a known pair of opposite side and angle. And how I usually think about this is that anytime I say a trig problem, that's the easiest thing I look out for first. So I look if I know any pairs. You see, if we know any pairs, then I say, all right, something like sine rule in the mix. If I don't see any pair, then I say, probably this is the cosine rule, or I'm gonna have to do something else. Right? So we could use the sine rule here because if you look, we have a known angle, 40 degrees, and we have a known opposite side, 13 meters. And in the other pair, we know the side, but we want to know the angle. So once we have those pairs that we can link up together, then we know, say, we're going to be thinking of the sine rule, right? So let's see if we can use that now. So by the sine rule, right? By the sine rule, what do we we know? We know that the sine of one to another is going to be equal to the opposite side is going to be the same all the way throughout. And I want to find the angle, so I'm going to put sine at the top. So you know, say here we have angle Q. So the sine of Q to its opposite side. So you know what? Well, since I already named a side Q, I'm just going to put the numbers. So the sine of the angle at Q, sine of angle QTS to its opposite side, 13, it's going to be the same as the sine of T to its opposite side, 10.8. Okay. So I'm seeing some answers in the chat. I'm seeing 1 and 2. Remember, you have to link the opposite side with the angle you're talking about. So always focus on the side that's in front of it. Okay. So now, do I know angle QTS? Yes. Sorry, not QTS. Sorry, 40. The sine of 40 to 13. Sorry about that. I know the angle here. I know that that's 40, and I can use that to help me find the sine at the angle T. And that's QTS. So let us, what can we do? We could probably, let's probably work it out. Let's probably work it out. So sine 40 to 13, we can put that in our calculator. Sine 40 to 13. So what's that when we work it out now? Sine 40 divided by 13, 0.049. If I'm doing it like this, I like to round it to 3 decimal place just to get it close to. So 0.049 is equal to sine T divided by 10.8. What next? Well, here, let me move this over. Oops. Here, I can multiply both sides by 10.8. So sine T is going to be equal to 10.8 times 0.049. Let's put that again in our calculator. So you see why I don't like to work it out, because no, I'm doing too much going back to the calculator, and this I could just throw it into it and stuff. But anyways, that's 0.5292. All right. And now, just like in the previous problem, we want the angle. So we need to do the inverse. So we can say T is equal to sine inverse of 0.5292. And again, calculator, that's going to be sine inverse of my answer. Oops. And that is 31.95. We don't want to round it to one decimal place. That was what we wanted to do for all our answers. That was what they told us. So that's going to be 32.0. You show the 0.0 to show that it's rounded to one decimal place. Okay. So this is T to 1 dp. All right. So that's the angle T. So we know that, therefore, I know I write it up properly now. Therefore, angle QTS is 32 degrees. Cool. Everybody clear so far? We're good? Okay. I see three things I want to touch on. One, so Christina got 32.2. Because you got that because you started to round off a little bit earlier. So not that see, I think we kind of look for a range of answers. So that would be, I think you'd still get it. I can't say for sure. Because we look for, I know they look for a little range of answers. So you would probably get it, but it's always safe to work it as closely to or prevent rounding as early as possible. So I always try to stay in the 3 or 4 decimal places, especially when we're working it, go down step by step. Okay? That's one thing. Serena was asking if we have to use the sine rule. In this case, let's see. If we look at it, let's see, let's ask ourselves then, could we use the other thing for non-right angle triangles, cosine rule? To use the cosine rule, I'd have to know the length of this side, or I'd have to know the length of all the sides. In this case, I only know the length of 2 sides, and I don't know the angle between them. So the sine rule would be the most appropriate, right? And then now, oh, Ninja is asking how long this session is. This session is finished. I don't want it to go more than an hour, and it's now 2 minutes to the hour. So for this last part, the area of triangle QRS, I want you to do that one on your own. So you can take a little screenshot, or you can come back to the video. You know, we kind of did one before where we found the area of the triangle. So you can try to find that area on your own. I'm gonna leave you up to that one. I know that you can do that one. All right. So we stop here for today. And as I said, for tomorrow, we're gonna look at some bearings. We're gonna see what we can do with some bearings. Kind of similar to these, but we're going to add some things that we need to know for bearings and when to use the rules. So the main thing I wanted to take away, when do I use the rule, right? And how to use it, right? So as I said, we'll stop here. If you're not subscribed already, you can subscribe. When you do that, more people know about it, more people can join, more people can come and learn. That's what we're all about. And tomorrow is bearings. Right? So I'll see you guys then. Christina, you raise your hand? Ooh.
Yeah.
What is it?
And I can go back to the question. I want to ask something. The one we did a while ago.
Yeah.
So what if you did make 10.8, like multiply by both sides and make sine t the subject and then just drop that in a calculator?
Let me see if I get what you're saying. So you say multiply both sides by 10.8.
Mm-hmm.
Oh, you mean instead of changing this? Or yeah,
Yeah.
get it still. Okay. All right. Let's from up here. So let's do that then. That is what I like. Because now you're going to get the exact answer. Because now if you do that, sine t split r, sine t is going to be 10.8 sine 40 to 13. So t is
Yes,
going to
sir.
be
That's what I
sine
thought we were going to do
inverse.
first. But
Sorry?
that's what I thought we were going to do at first. But when you did it your way, I think I
Yeah.
get it better like that.
Oh,
I think I would prefer to do it like that.
yeah, I'm saying it's better to stick to it this way. I just did it the other way just for
But I
everybody
still
to see.
understand the other way.
Oh, good. But I like to do the exact one. Because then with the exact one, you don't have no bag of calculation. No, as I say, once you have your good calculator, your good up calculator, all you do, they just throw it in straight. So that's sine inverse, get a fraction, 10.8 sine 40, all divided by 13. And now you get an exact answer. So that would be, the exact answer is really 32.3. So your answer actually closer than mine, Christina. Your answer closer than mine. But
I
they
feel like
take
they're
that,
the same thing.
the 32.3 and the 32.0. It's not, I don't say it's exactly the same. I don't want to say it's the same. So,
But
you know.
it's just the range.
Yeah, they kind of look for a range. I mean, if I'm marking a CXC paper and I say 32.1 or 32.2, I'm not going to kill you, you know. But to be safe, the safest way is to just keep it exact. And what can help you to keep it exact is getting a good calculator. Once you have a good calculator, you don't have nothing to fret about. All right. So yeah, we'll stop here for today, everybody. And tomorrow, I'll see you guys tomorrow at Bearings. Thanks for coming out. And I'll see you tomorrow, same time. Later.
All right, sir.
All right, cool. Okay.
Thank you. Bye, sir.
Bye. Take care. Oh, for those, I'm seeing some persons still on YouTube. Transformation and reflection, we might. Yeah, we probably might do that closer to the exam. Yeah, oh, I see Ninja saying the same thing. Yeah, we might. I'm not gonna say no, we might, probably. Let's see. Let me get closer to it. Let's see. Later.